Let me start by explaining the problem that your caching solves. We'll take an example. Suppose you are running a local news website and a breaking news it breaks out and suddenly a celebrity tweets your link. When that link is tweeted by a celebrity, then your requests to your website, which are normally say 10 users per minute, it will spike to 10,000 users per minute. It might be possible. If caching hasn't been implemented, then every single request from every user that's visiting your website, from every 10,000 users that are visiting your website, if caching hasn't been implemented, then every single request will go through the long process of a database query, of building up the comments, of reading the author's bio. So it will actually be a full scale process, and the full 10,000 requests, they are going to lead to a complete jam of your website. Your CPU, the database CPU, it will hit 100%, queries will start to pile up, and eventually your site will time out. And it's therefore the embarrassment would be that you will have just missed your biggest traffic spike because the database couldn't repeat the same work 10,000 times fast enough. This is the actual basic problem if you do not implement caching. Now, on the other hand, if caching had been implemented, the first user, it will trigger a query to your database. The result of that query, whatever it is, because it's a news story, the things are not going to change within, let us say, 5 or 10 minutes. So if the first query, it simply makes a request to your database and collects the news item and collects the whatever the biodata of the author or the list of comments, and it caches all of them. It puts all of them in a RAM in your memory. This means the remaining 9,000 requests that are going to hit your server, they will not have to go through the complete process of running the whole database query. They will get their data immediately from the RAM. Your article will get delivered immediately, instantly from memory. Your database will stay chilled out, it will stay normal, slow at 2% CPU in such a case. So caching will help you speed up your response to the end user, that's one thing, and it will also help your CPU from running at 100%, and it will help a more efficient website. You will be able to serve all the requests instantly. We can take another example. Suppose you built an app that shows product prices in 50 different currencies. Quite common. To get accurate rates, you use a professional financial exchange API. And let us suppose this API charges you 1 cent per request, which is quite common. So every time a user refreshes their shopping cart, your app calls the API. If you have 1,000 active users that are browsing your website, which is again very normal, you might be making 1,000 into 5,000 API calls per hour. And that would be just $50 per hour. You will be spending $50 per hour just for the currency data that hasn't even changed in the last 10 minutes. The scenario will change if caching were implemented. In this case, you fetch the exchange rates once and cache them for 30 minutes. How does it matter? Currency will not change within 30 minutes. Now, whether you have 10 users or whether you have 10,000 users, you only make one API call in every half an hour. So what is that? You will be able to save hundreds of dollars in a day. Let's take another example. I have another interesting example. Your company has a dashboard that shows total sales this year grouped by region, product category, and salesperson. To calculate this, the server has to scan 10 million rows in your SQL database and perform complex mathematics. So every time the Chief Executive Officer CEO opens the dashboard or changes a filter, the server will spend 15 seconds crunching the 10 million rows. The UI will feel laggy and the CEO will think that your app has broken down. If caching were implemented, you can run that heavy calculation once an hour or use a background worker to update it. When the CEO opens the page, the 15-second calculation, the longer calculation is already finished and sitting in the cache. The page loads in 200 milliseconds. So this is what is the power of caching, which you might already be knowing also, but I have given you a few examples. Now so far ASP.NET developers have implemented caching in two ways, and both have shortcomings. The first approach is called the L1 cache, where iMemory cache is implemented. The interface iMemory cache is implemented. The L1 cache basically uses app's RAM, and therefore it's incredibly fast because it's right there in the app's RAM. So L1 is one way of implementing caching. But L1 will become problematic when you have so much spike that you have to scale to 3 servers immediately in real time. In this case, all the 3 servers have different versions of the same keys because RAMs of each are physically different. Each server has its own RAM. Now, which of these servers has the correct data? We have no control over 3 different addresses. The solution to the problem faced in L1 cache is to use Redis via iDistributed cache. This is called L2 cache. It's great for consistency, but now every single GET request has to cross network boundaries and serialization, deserialization has to take place each time. Each of the 10,000 requests has to pass through a chain of networks which has its own problem. The distributed cache of Redis needs network communication, and that's obviously costly for every 10,000 requests. So now we have a scenario where your L1 will be inside your RAM, but it can't span multiple servers. But if you do not bind it to a particular server and you use an L2 system where you use a Redis database for storing your cache items, in that case, your network is the cost. So both L1 and L2, they have their own pluses and minuses, and neither of them is perfect. Now .NET 9 and .NET 10, they provide a new strategy called HybridCache. HybridCache is not actually a different category of cache, it is not a different type of a system. Both L1 and L2 implementations, they are necessary for HybridCache to function. So HybridCache is actually dependent on the implementation of L1 and L2, and both have to be implemented. HybridCache is not a separate or not a different type of caching mechanism. It's a sort of a manager that directs and controls L1 and L2 caches. Both L1 and L2 are controlled by the HybridCache system. So I'll say hybrid caching is a sort of a system, is a sort of a software that will actually control both L1 and L2, and both L1 and L2, they have to be implemented. So now let us consider a situation where 10,000 requests have hit at the same instant of time and a sort of stampede has taken place. And also suppose that the data in cache L1 has become stale and inaccurate due to expiry. So let's suppose that the data in L1 is not available at the moment, or is, let us say, closed due to the expiry of time. So 10,000 requests have hit your server, and L1, the immediate source of memory, the immediate source of data, it is not able to service the requests. The data could have become unusable when it has been cleared by another part of your program also. And there is no communication between the two sections. So what I'm trying to say is that Let's suppose 10,000 requests have hit your server.